Hi there, this is a lot of work. Hi there, my name is Celine. Um, So the problem you're going to solve today is invert binary tree, and this is another very common coding interview problem, and it is definitely a good idea that you need to know how to solve this in case you're asked in an interviewing setting. Also, to solve this problem, you need to make sure that you understand the concept of binary trees, know how to traverse a binary tree, know the three processes of traversing a binary tree, in this case pre-order, post-order, and in-order traversal. And by knowing that, you'd be able to approach this question because it's actually quite simple. So when you look at the question here, it tells us to invert a binary tree, and we're given this example. We're given an input of this tree here, and this is the output. So if you look at the input basically and the output, you notice that the output is basically like a mirror of the input. So basically what they've done is that they've swapped the left with the right. So if you look at 479, we have 479 here, and then 6, and then we have 2 3 2 3, which is the left, and 1. So basically what it means when someone tells you to invert a binary tree, they're telling you to swap the left with the right. And we're gonna have a visual representation to see how this works. So let's say we have this tree here. We have 6, we have 4 and 8, and we have 2 and 5, and we have 7 and 10. And we're supposed to invert this binary tree. And like we have talked, basically when you're told to invert a binary tree, what they mean is that you're going to swap the items on the left with the items on the right. So when this tree is inverted, we're going to have 6. And then when you swap 8 and 4, and then we're also going to swap 10 and 7, so it's gonna be 10 and then 7, and we're also going to swap 5 and 2, so we're going to have 5 and then 2. So after this tree is inverted, this is what we get as our final result. So this tree here is inverted. And one thing that you need to remember always is that whenever they tell you to invert a binary tree, all you need to do is that you need to swap the items on the left with the items on the right. And so we're going to look at two ways of solving this in code. We're going to have a recursive solution. We're also going to make use of an iterative solution. And let's go ahead and look at how to approach these two solutions in code. So we're going to start with the recursive solution, and this is how to go about it. We're first going to check whether the root exists or not. So we're going to have if not root. We'll go ahead and return none. Otherwise, what we're going to do is that we're going to call two recursive functions for the left and the right. So we're going to have self.invert, the invert tree, and then we'll have the root.left. We do the same thing for the right, so we'll have self.invert tree, and then we have root.right. Afterwards, what we're going to do is that we're going to swap the left with the right, and Python allows you to swap left to the right with just one line. So basically it's going to be root.left root.right is equals to root.right and root.left. After that, we are going to return root. So we're going to return root, and that is how to approach this. So let's go ahead and test and see if our code works. And yes, it has been accepted. If we go ahead and submit it, our code has been accepted as well. And so basically, as you have seen, we have swapped the left to the right, and our code will keep being called recursively until we finally get the desired result. So the time complexity here is ON, and this is a recursive way of approaching this. And we're going to look at another way of solving this problem, which is through iteration, and we're gonna be using queues. So let's have a look at how to do it. for the iterative solution, you're going to make use of queues, and in this case we're going to use decks because decks have constant time whenever you want to remove or add something, so they are more convenient in this case. I'm going to create a variable queue and have collections.deck, and then I'm going to have the root here. So I'm going to check whenever there's something inside the queue. So I'm going to have while len of queue. I'm going to do a couple of operations, and so whenever there's something inside the queue, what we want to do is that we want to remove it and add it to a variable. So I'm going to create a variable here, and I'm going to have queue.popLeft. This is to remove the item from the queue, and then if not card, so this checks if there is a node or not. So if there is no node, what you're going to do is that we're going to continue and move to the next iteration. So I'm going to have continue. Otherwise, what we have to do is that now we're going to swap. So I'm going to swap the left to the right. So current.left and current.right is equals to current.right and current.left. And then after doing that, we're going to add whatever we've swapped to the queue. So it's gonna be queue.append current.left, and then we have queue.append current.right. And then after doing that, we want to go ahead and return the root. Let's go ahead and check our code. And as you can see, it has been accepted. Looks like it works fine, and I'm then going to go ahead and submit it, and yes, our code has been accepted, and it's actually quite fast. So that is how to approach this using queues. You can also approach this using stacks. So just in case they ask you in an interviewing setting to give a solution that is not a recursive approach, be sure to understand how to approach this iteratively. And that is the two ways of approaching this problem in case you're asked in an interviewing setting. I hope you've learned something, and see you on the next problem. Thank you.